In this video, we're going to look at several different types of concentration problems, all still dealing with the idea of molarity. So we know that molarity is a measure of concentration, and we know that molarity, or capital M, equals moles divided by liters. And we know that that is moles of solute divided by liters of total solution. Okay, we've looked at this several times in comparison between molarity and molality. We know that molarity is moles of solute divided by liters of total solution, and that is measured in capital M is the unit that we use for that. Okay, so we're going to read the problems, and we're going to look at the problems and see what we need to do based on our T-table. We know our T-table is capital M molarity equals moles divided by liters. So let's read our first problem. Problem number 3 in our worksheet is based on I&B page 6. So if you turn to I&B page 6, you're going to see a worksheet called Concentration Practice Problems. It looks like this. And we're going to be working on problems 3, 7, and 10 together. Now I only assigned the odd number problems, but we're going to look at the 3 of these together in order to best understand what we're doing. Okay, problem number 3. 3 says, what is the molarity of a 5.30 gram Na2CO3 solution dissolved in 400 milliliters? Okay, so I need to know what is the molarity. So when I make my T-table, I know that I'm going to be looking for molarity. So if I cover up molarity, my equation is going to be moles divided by liters. So I know I'm going to need moles divided by liters. Okay, now liters is solution, and moles is going to be my solute, or my thing being dissolved. Well, I know that I'm going to be dissolving 5.3 grams of Na2CO3, but I can't use grams, I need moles. So I'm going to have to first convert this into moles. So let's do that over here on the side. We have 5.30 grams of Na2CO3. In order to convert that into moles, I need to drop the grams to the bottom and 1 mole on the top. The mass I'm going to put on the bottom is the mass of Na2CO3 as based on the periodic table. So let's look it up and let's figure that out. Na is 22.9, and I have to times 2 because there's 2 of them, plus carbon, that's 12.01. Now I'm going to add oxygen times 3, 15.99 times 3. You'll notice in my calculator I put that in parentheses so that it would understand the PEMDAS rules. So the answer that I get from that is 105.78. I'm just going to write 106 down here. So I need to take 5.30 divided by 106. 5.30 divided by 106, or my molar mass, and I get 0.05. So I know that I'm going to need 0.05 moles, or I'm going to use 0.05 moles. So over here in my problem, where I have moles, I'm going to write 0.05 moles. Now I'm going to need to divide that by liters of solution. Well, my equation, or my problem, says that I have 400 milliliters of solution. I'm going to need to turn those milliliters into liters. Well, I know that if I divide by 1,000, and I take 400 divided by 1,000, I'm going to get 0.4. That 0.4 is my liters, so 0.4 liters. So I took my milliliters, divided it by 1,000, and I got 0.4. So now I just need to do my math. 0.05 moles divided by 0.4 liters, and I'm going to get 0.125, and I know that my unit is capital M molarity. So that is in the molarity, or the concentration of my solution. Moles divided by liters, I had to turn my solute into moles. I had to convert milliliters into liters by dividing by 1,000, plugged them into my problem, and I got the answer. Okay, let's look at number 7. Number 7 says how many moles of NaCl are in a 10 milliliter solution of molarity of 2. Okay, so I'm going to put my table in. Molarity equals moles divided by liters, and I want to know how many moles. So I'm going to be looking for moles. If I'm looking for moles, I'm going to have to do molarity times liters. So my equation is going to be molarity times liters. Well, I've been given a molarity of 2, so I can put in molarity of 2. Now another way of writing molarity is writing moles over liters, and that's going to help us cross out our units. It's the same thing as writing M, because M just means moles divided by liters. So we have 2.0 molarity, or moles divided by liters, times our liters. Well, the volume that we were given in the problem is 10 milliliters, but I know in order to get to liters, I just divide by 1,000, so 10 divided by 1,000 is going to give me 0.01 liters. So I'll plug in 0.01 liters here. My liters will now cancel, leaving me with moles, which is what I wanted. So I'm going to take 2 times 0.01, and I'm going to get 0.02, and my unit remaining is moles. So that's how many moles I would need. 0.02 moles of NaCl in order to get the solution that I would desire. Just use my T-table, molarity, moles divided by liters, plugged in what I had, making sure I had the correct units. I remembered that molarity, or capital M, means moles divided by liters, so I could see what would cross off. Okay, last practice problem, number 10. Number 10 says, what volume in milliliters of an 18 molar H2SO4 solution is needed to contain 2.54 grams of H2SO4? Okay, let's set up our box. We know molarity equals moles divided by liters. It's asking me for what volume. Now it does ask for it to be in milliliters, but let's just start with volume. Volume is going to be liters. So I know the equation I'm going to need to use is moles divided by molarity. So moles divided by molarity. Okay, so let's see what I have in my problem. I know that I have a solution with an 18 molar concentration, so I can put 18 molar on the bottom, and then I need to figure out my moles. Well, I've been given 2.45 grams. Can I get from grams to moles? Yeah, so I'm just going to do that conversion here. 2.45 grams of H2SO4, grams drops to the bottom, and I'm converting this into moles. Well, the grams are going to be the mass in the periodic table. So I'm going to take 15.99 times 4 for oxygen, plus the mass of sulfur, which is 32.06, plus 2 hydrogen, so 1.007 times 2. I put that in parentheses in my calculator, and so I get my mass to be 98 grams for H2SO4, or sulfuric acid. So 2.45 divided by 98 gives me a mole value of 0.025 moles. So that's what I can put on the top here for moles. 0.025 moles. Now remember, molarity meant moles divided by liters. So my moles will cancel, leaving me with liters when I do this. So I have 0.025 divided by 18, and the answer that I get is a really small answer. The answer that I would get would be 0.0014 liters of solution is how much I would need. Now, my problem, I'm actually not done yet. My problem asks for it in milliliters. Well, if I have liters and I need to get to milliliters, I would do the opposite of what I usually do. Usually I have milliliters and I divide by 1,000 to get liters. So since I have liters and I want to get to milliliters, I'm going to multiply that by 1,000. So times 1,000, and I get 1.39 milliliters. And that is my final answer. And realize that I took the 0.0014, it was actually 0.00139 liters, multiplied it by 1,000, and I got 1.39 or 1.4 milliliters as my answer. Okay, concentration practice just involves manipulating the moles, molarity, liters equation. We know that we cover up whatever we're looking for, and we double check the units, and then we multiply or divide depending on what we are given. Always make sure when we are finished that we go back to our answer and we double check that it's in the unit that the problem asked for. I almost messed up on number 10 because I got the answer in liters, but the problem asked me for milliliters. So I had to remember to go back and multiply by 1,000 to turn liters into milliliters. These are practice problems on IMB page 6, concentration.